Now students, magnetic is that substance, right, which has got a very strange capacity of being able to attract certain objects toward itself, right. Now I got here a substance, if this should be called as a magnet, then if I take it as some iron filings, you will find that it is able to attract these iron filings, right. Now this region where its strength is highest is called as a pole of a magnet. A magnet has got always two poles. There cannot be a magnet with a single pole. Let us see whether there is an opposite pole here or not. Yes, you see here that you got a huge bunch of iron filings attached to one of the poles here, on north pole on this side and south pole on this side. So this is the property of a magnet. Now this magnet does not only act in this region. Depending on the strength of this magnet, there is a whole sphere or space around it, right, in this orientation, and also in other orientation. So all the three axes, the x-axis, y-axis and the z-axis, there the effect of this magnet is felt. That region around the magnet into which its field is going to be felt is called as field of this magnet. And this field of a magnet has very, very unique properties. It's got very unique properties. And all of us must also remember that Earth itself is a huge magnet. Earth itself is a huge magnet. And Earth has got a north pole and a south pole, and I have taken here this plate, and on which at the bottom of this plate I have fixed a bar magnet, right? I have fixed a bar magnet here, and I have fixed it in such a way that the north pole is pointing toward the geographical north. This is our geographical north, and I have placed the north pole of this bar magnet also in the same direction. I am going to place it here, and this position is called as north pole of the bar magnet facing the north pole of the Earth. Now how do we understand the nature of the magnetic field here? Again, to do that, I am going to take a few iron filings, right, and I am going to just sprinkle these iron filings on this board, underneath which is a bar magnet whose north pole is facing the north of the Earth. Let us see what pattern does it make. Now you see that the beautiful arrangement of these iron filings is taking place, and the magnetic lines of force always start from the north pole and go to the south pole. And please understand, they are in the front of this magnet, they are also in the back of this magnet. Even if I hold this magnet like this, you will see that the fields are below the magnet and above the magnet. That is an important concept you must understand, right? When you see on the paper, you see that this is only in one plane. It is not like that. It is in all the planes. It's all around the magnet that the lines of force start from the north pole and go on to the south pole. This is the situation where the bar magnet was placed in such a way that the north pole of the bar magnet was facing the geographical north. Please observe these findings and record them properly. Now what we will do is, I will take out these iron filings once again and then place this bar magnet in such a way that the north pole of the bar magnet is now going to face the south pole of the Earth. And then let us observe the difference in these fields. Let us do this activity once again to understand the pattern here. Yes, the lines of force are starting in this pattern, going from north pole and going to the south pole. Right? Now let me take out all these iron filings. Right, now I have taken here. Now this was the north pole of the bar magnet. I am going to place in such a way that the north pole of the bar magnet is now facing the south pole of the Earth, or geographical south. And now we are going to do the same activity once again and observe, are the magnetic lines of force showing the same pattern or there is any difference. So we will take these iron filings, again I will sprinkle them on this, and you will notice that there is a difference in the pattern. There is a difference in the pattern. Earlier, when the north pole of the bar magnet was facing the north, the lines of forces were going like this, and now here they are more separated. If you compare this pattern with the previous pattern, right, you will be able to make the difference here. The fielding is stretched like this, because now these two magnets are in conflict with the Earth's magnet, and then therefore the resultant is different. And the resultant is different, it is going to be shown on the difference in the patterns. There is one type of pattern when the north pole of the bar magnet was facing the north pole of the Earth, and the pattern will be different when the north pole of the bar magnet is facing the south pole of the Earth. This is very important because this tells us what is going to be the strength of the bar magnet. It depends upon how you place the magnet. So your orientation in space is of great importance as far as understanding the strength of a magnet is concerned. Did you understand it? Thank you.